My dear student, we will discuss today in given method how we comparison of PD between three voltmeters, and here three voltmeters A, B and C are connected as shown in the figure. When we establish the potential difference across X and Y, then obviously current will flow through them. Actually, we discussed today two important factors. First of all, I have to solve this problem, and how can proceed this type of problem? How can comparison potential difference across A, B and C voltmeter and which are connected as shown in the figure. And in next lecture, we will discuss about EMF and PD. EMF, and that is the electromotive force, and PD, that means potential difference. And very important concept of electricity of class 12 in chapter 3. So, first of all, we have to proceed this type of questions. And my process is related to, we want to give the differences between potential difference across these three voltmeters. First of all, we establish the potential difference across X and Y in given networks. Here, X and Y, the two terminals, and when we connected a cell across these two terminals, then potential difference established and current will flow through them. And let us suppose that when I current is flowing through the circuit, then this current, when it reaches at this point, it will disperse. And let us suppose that here I1 and here I2. And now the charge is conserved, and so the total algebraic sum of current will be equal to this current I, and when these two currents will meet at this point, then current will equal to I. At first, we have to get the equivalent resistance of these three given voltmeter. And we know that, and we see here already, these two resistances are connected in parallel. So, the equivalent resistance will be 1.5 R multiplied 3R divided by 1.5 R plus 3 into R. Because already in parallel connection for two resistance, the equivalent resistance will be equal to product by sum. And here, the equivalent resistance of these two resistance are connected in series with this resistance, and so the equivalent resistance will be R plus the equivalent resistance of these two resistance. And as first of all, R equivalent, R XY, that will be equivalent resistance across X and Y. R plus these two resistances are in parallel, and so its equivalent 1.5 R multiplied 3 into R divided by 1.5 R plus 3 into R. It will give the equivalent resistance across X and Y. And we solve it. R plus here 1.5 R multiplied 3R, 1.5 R multiplied 3R divided by 1.5 plus 3, 4.5 R, and here also 1.5 multiplied 3, R plus it will be equal to 4.5 R square, R multiply R square, 1.5 multiply 3, 4.5 divided by 4.5 into R. And here it will cancel, and so R plus R will be equal to 2R. And so in given network, first of all, we get the value of equivalent resistance across X and Y. And you remember, as according to questions, we have to establish a comparison of potential difference already dispersed across here 3. What would be the potential difference across voltmeter A? What would be across B and what would be across C? We have to see separately. Here X and Y, the two terminals, and already we will get the value of equivalent resistance across X and Y. Now, what would be the value of this current under regarding the equivalent resistance across XY? By Ohm's law, I बराबर V upon R equivalent, and so V divided by R equivalent will be equal to 2R, and so here the current will flow through the circuit, total current will flow through the circuit, and which is equal to V upon 2R. But here, what would be the value of I1 and what would be the value of I2? And it is a difficult task to get the value of separately I1 and I2 among this total current. But here we see already these two resistances are connected in parallel, and we discussed and we told already in previous class, in parallel connection potential difference will remain same, and hence the PD across this point and this point will remain same already. And when PD across this wire, I1 multiply 1.5R, because by Ohm's law V will be equal to IR, and so I1 multiply 1.5R will be equal to I2 multiply 3R. I2 multiply 3R. It can be written as according to the concept of in parallel connection, the PD will be same. And so the PD across this wire will be equal to this, and PD across this wire will be equal to this, and will be equal to, and here 1.5R, 3R, it will be cancelled by 2, and so I1 upon I2 will be equal to 1.5 and 3, 1.5 by 10, and here 3. So I1 upon I2 will be equal to 10 multiplied 2, that will be 20. Because I1 multiply 1.5R and here R, it will be equal to 2. Because 1.5 there multiply 2, that will be 3, R will be cancelled, and so I1 upon I2 will be equal to 2. Now we add both sides 1. I1 by I2 plus 1 will be equal to 2 plus 1, that will be 3. And here I1 upon I2. Here I1 upon I2 plus 1 will be equal to 3. And so it will be written as I1 plus I2 upon I2 will be equal to 3. It will be equal to I, because I1 plus I2 will be equal to I. So I upon I2 will be equal to 3. Hence, I2 will be equal to I upon 3. But we have the value of I here, V upon 2R. So, V upon 6R, the value of I2. We get here already the value of current I2 and with passing through voltmeter C, then I2 will be equal to V upon 6R. Now, we will get the value of PD across this wire because we get the value of I2. And so, PD across C, VC will be this current I2 multiply resistance 3 into R. I2 will be equal to V upon 6R multiply 3R, and it will cancel, that will be V upon 2. The voltage across C will be equal to V upon 2. If I2 will be equal to V upon 6R, then we will get also the value of I1. I1 plus I2 will be equal to V upon 2R. And so I1 will be equal to V upon 2R minus I2, and which is equal to V upon 6R. It will be equal to 6R 3V minus V 2V upon 6R. Now it will be equal to V upon 3 into R. Here I1, we get the value of I1 V upon 3R, and so this current passes through this resistance, and hence PD across B, PD across B, so VB is equal to I1 multiply resistance of B, that will be there, I1 into 1.5R, and here I1 is equal to V upon 3R, V upon 3R multiply 1.5R, and it will cancel here V upon 2, V upon 2. And so we get already the two potential across B and C. Here potential we get V upon 2, and here also potential get V upon 2. And now we get the potential across R, V upon IR, VA. I we have V upon 2R multiply R, V upon 2. Very important and interesting results here. In these given networks, we see here the potential across A, V by 2, potential across B, V by 2, potential across C, V by 2, and so the potential for every these three given voltmeters will remain same, and so here potential will remain same everywhere. Thank you, Mr. Dhananjay Kumar, PGT Physics, Urbine Modern School.